Okay, so my first problem is problem 15, and it states an 8 times 10 to the fourth kilogram spaceship is at rest in deep space, and thrusters provide a force of 1,200 kilonewtons. The spaceship fires its thrusters for 20 seconds to then coast for 12 kilometers. How long does it take the spaceship to coast this distance? So it gives us two values in which we're able to use. We have the mass of the spaceship and the force of its thrusters, and this should be kilonewtons, not newtons. And with these two, we can go back to the lecture in which we talked about mechanical equilibrium, and it shows the equation F equals ma, which is just force equals mass times acceleration. We're given two parts of this equation, so it makes sense that we would probably need the third part for later answering the question. So we have our force, which is 1.2 times 10 to the 6 newtons, because we convert the 1,200 kilonewtons into newtons for this equation. And then we have, it already gave us the mass in kilograms, so we're able just to plug that in, and then our A. And you can find that when you divide this over, A is 15 meters per second squared. Now, we need to find our velocity, because with velocity, you can find distance easier than you could with acceleration. And our velocity equation will be v equals velocity initial plus at. Our velocity initial was 0, just because like we're going to start at the point after we had traveled the first 20 seconds, and then our 15 meters per second squared acceleration, and then our 20-second time. So this gives us, like I said, the velocity at the end of our acceleration, which gives us 300 meters per second. Now we can use that velocity to find our position, but we already know our position as 12,000 meters or 12 kilometers. So what are we trying to find? Time. And within this equation, there's also time in two different spots. But we have our initial position, which we're going to count as 0 because we're kind of just starting this at the end of the acceleration. And then we have our velocity as 300 meters per second, our t, which we're trying to find, and then our 1/2 at squared. Luckily for us, this will cancel out because our acceleration is now 0 since we were coasting. Now we have our position equaling our velocity multiplied by our time. When you divide your velocity over, your meters will cancel out, so your only units left are seconds, and you have t equaling 40 seconds. And we have this graph showing that the velocity is getting is increasing at the same rate, which is the acceleration, and then we have the constant velocity at 300 meters per second. And then we have our position graph starting at the 20 seconds. So this is 20 seconds. And going forward, we have it as a constant increase in position because of a constant velocity.